All right, here we go. Section 3.3, and no real new ideas here. Just kind of putting a bunch of ideas that we've already covered, putting them together in conjunction. So we're going to be graphing, but these are inequalities. So we got to make sure that we are solving where our solutions are at. And so we've got y equals x squared minus 2x minus 8. And I'm going to start just by factoring this to get x minus 4 and x plus 2. So y is greater than x plus 2 and x minus 4. And so my roots are going to be at negative 2. Actually, let me go ahead and go with the red. My roots are at negative 2 and 4, meaning I already know my axis of symmetry. If I've got these 2 points and they both have a y value of 0, then they're well, any 2 points that are on the same y value have to be symmetrical. So here's my axis of symmetry at x equals 1. And that's going to help me find my vertex. So if I plug in 1 squared is 1 minus 2 minus 8. So 1 minus 2 is negative 1. Minus 8 is negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Just off the graph. There's our vertex at 1, 9. All right, and then since this is just a y is greater than, not greater than or equal to, my graph is going to be actually a dotted line, because all the values right on that line are not solutions. They'll give me values like 5 is greater than 5 or 4 is greater than 4, and those numbers aren't greater than themselves, so they're not solutions. So we've got the dotted line there, and maybe we can put a little bit stronger in there, but still dotted, not solutions. And then we're left with y, and y being greater than. So in case you're not remembering, do I shade above or below, you can think about, okay, well, y is that talking about left or right or up and down? And it's talking about up and down. And we're saying that that up and down is greater than. So where are my y values greater than? I'm going to go up. And those are where my shading can be. You can think through it about what's happening with y. Or you can grab a test point and choose any point that's above or below your line but isn't on the line itself. So for example, we might have chosen 0, 0 and tested that. If I plug in 0 for y, is 0 greater than, and then let's plug in 0 here. So 0 squared minus 2 times 0, that's 0, minus 8. Is 0 greater than negative 8? And yeah, it is. And so I'm going to shade where that 0, 0, where that point's at. And so here's our solution for number 1. Next, I've got 1 minus 4x minus 5x squared is greater than or equal to y. So I'm going to reorder this and get it into a shape that, or a factor form that's useful to me. So I'm going to have negative 5x squared minus 4x plus 1 is greater than or equal to y. And I can factor this. First off, I'm going to factor out a negative. So negative 5x squared plus 4x minus 1 is greater than or equal to y. And I'll come over here and use some of the space over here. That's going to factor out to be, let's see, what is that going to be? So y, I'm going to change my y to the other side, is less than or equal to negative 5x minus 1 times, oh, ran out of room. Let me make this a little bit bigger. All right. So y is less than or equal to negative 5 times 5x minus 1 times x plus 1. And so I know my roots are going to be at negative 1 and what is that? 1/5. Okay. Come on down and graph those. So negative 1, positive 1/5, right around there somewhere in my axis of symmetry then. So go ahead and I can either find the average between those. So let's see, 1/5 plus or minus 5/5 gives me 4/5, -4/5, which then divide that by 2. So negative 4/10 is going to be my -4/10 or -2/5 is going to be my axis of symmetry. -2/5. Plug in -2/5 and work your way on through, and we end up getting a y value of 9/5. So my vertex is at -2/5, comma 9/5, and we've got 9/5 is just below 2. There's that. There's the vertex, and this time it's y is less than or equal to. So I'm going to graph a solid line this time. Solid line, because all the values right on the line are solutions that are equal to, and shading where y is less than, so shading below. And again, if you're not sure about where to shade, grab a test point. So I can tell that 0, -1 is certainly below my graph. And so if I plug in 0 for x, 0 times -1 is -1, and 0 plus 1 is +1. So -1 times negative, and I'll come up with 1 is greater than, and my y value of -1. Is it true that -1 is less than 1? Yeah, it is. And so that's why my solution is towards where that test point was of, I chose 0, -1, that point right there. All right, hope that helps.